Okay, so let's keep on going with this. I know probability is not easy, okay? I understand it's not easy. So let me see. All right. So now we did some terminology. Well, let's get to the actual definition of probability. What's nice here is that we're going to assume all the outcomes are equally likely. So like if you're tossing a fair coin twice, any of these outcomes are equally likely. You know, you're just as likely for the coin to land tails up twice as it is to land heads up twice. You know, if you're rolling a fair six-sided die, you're just as likely to roll a 2 as you are a 4 or 3 or whatever. You know, there's no cheating here, so to say. For any event E, then, we denote the probability of event E by this, P of E. And the probability is the number of outcomes corresponding to event E divided by the total number of equally likely outcomes. So it's the number of outcomes that are in event E. Remember, an event is a collection of outcomes, right? So it's the number of outcomes in event E corresponding to it divided by the total number of equally likely outcomes. The total number here is usually the sample space size, the size of the sample space, meaning how many outcomes are in there. And the numerator here is how many outcomes are in event E. That's what probability is. So, okay. As an example, let's suppose we roll a fair, you know, a six-sided die. I mean, it's fair unless stated otherwise. What is the sample space then? You know, so let's find that. We're going to find the probability of rolling a 2 and the probability of rolling an even number. Well, we already saw the sample space, right? You know, you're rolling a six-sided die, so the sample space would be a 1, a 2, 3, 4, 5, or 6. You know, each side is labeled by a number. Okay, well, rolling a 2, right? How can we roll a 2? Well, there's only one way we can do that, right? Rolling a 2. So what's the probability of this event? 1 over 6, right? The sample space, you know, how many outcomes there are altogether, the total number of equally likely outcomes, right? Well, there's 6. And how many events correspond to, how many outcomes correspond to event E? Well, in this case, event E is just rolling a 2. Well, there's only one outcome with that, rolling a 2. So 1 out of 6. What about rolling an even number? What about that probability? Okay, well, again, there are 6 outcomes altogether, right? In the experiment, that is the total number of equally likely outcomes, right? There are 6 outcomes altogether. How many outcomes correspond to rolling an even number? Well, we can roll a 2, we can roll a 4, or a 6. There are 3 even numbers. So the probability of rolling an even number is 3 out of 6. I know it's tempting to write this as a half. I would personally just leave it as 3 over 6. I mean, it's not wrong to write this as 1 over 2, but it's really better to not reduce it. Okay. Are there any questions about this example or about anything we've done so far today? Okay, let's keep going then. Here's another example. Suppose now, though, we're going to roll a 12-sided die. So again, each side corresponds to a number. I'm not sure if there is a 12-sided die. There could be, but let's assume there is one. So what is the sample space? We'll find that first, right? We'll find the probability of rolling an 11 and the probability of rolling an odd number. Okay, so for the sample space, well, what's the sample space? Well, again, each side is labeled with a number, 1 through 12, an integer that is. So the sample space would be 1, 2, 3, up to 12, right here. 12. You know, these are the numbers you can roll. Hence, these are the outcomes from rolling a fair 12-sided die. So this is what we get. Okay, well, they're all equally likely, right? So what would the probability of rolling an 11 be? Well, again, it's just like before. How many ways can you roll an 11? Well, only once, only one way. And how many outcomes are there altogether? 12. So the probability of rolling an 11 is 1 out of 12. What about odd numbers? Rolling an odd number now. Well, how many odd numbers are there? We have 1, 2, 3, 4, 5, 6. So there are 6 outcomes corresponding to rolling an odd number. In other words, there are 6 ways we can roll an odd number. So now the probability is 6 out of 12. Again, the 12 because there are 12 equally likely outcomes altogether. Okay, that's fun. Are there any questions on this? Again, this may not make sense at first, okay? I understand that. Okay, but again, this is not easy stuff. Believe me, I understand. Probability can be tough. Okay. Here, I just really want to go through what a deck of cards is. You know, a standard deck of 52 playing cards, right? Well, remember, there are, you know, the cards are labeled with a suit and a number, or they could be one of these cards. Sorry. In other words, in a deck of 52 playing cards, right, there are 4 suits. We have spades, diamonds, hearts, and clubs. So each card in the deck is labeled with one of these suits. And in fact, in each suit, there are 13 cards. The cards in each suit, okay, there are cards numbered 2 through 10, you know, 2, 3, 4, and so on, up to including 10. And there's also in each suit a jack, a queen, a king, and an ace. Hence, in each suit, there are 13 cards. These cards here, the jack, the queen, and the king, they're just called face cards. So altogether, there are 52 cards to play with. Okay. Also, there are no jokers in the deck of 52 playing cards. That's just, again, a convention we're taking. There's no jokers. All right. So that's in a standard deck of 52 cards. Also, again, we're assuming all outcomes are equally likely. So we're going to assume that the cards are not marked in a way that we can tell beforehand what card we're playing. So for instance, let's suppose we have such a standard deck of 52 playing cards. And let's say we decide to draw a card at random. What's the probability of choosing a king? And then also find the probability of choosing a club. You know, in other words, a card from the suit of clubs. Well, again, what would the sample space here? That would be all 52 playing cards, right? As we said on the previous slide, all 52 cards. Now, how many kings are there in such a deck? There are 4 altogether, 1 for each suit. Okay, so there are 4 kings. What's the probability of choosing a king? Well, there are 4 kings in the deck that we can choose from. And there are 52 cards altogether, so the probability would be 4 out of 52. 4 out of 52, right? You know, what outcomes correspond to choosing a king? Well, you basically can choose a king from the suit of diamonds, from the suit of hearts, and so on. And there are 4. So there's 4 ways that event can occur, and there's 52 outcomes altogether. 4 outcomes with that event, excuse me. The event of choosing a king. What about choosing a club? That is a card from the suit of clubs. Each suit has 13 cards. So there are 13 cards from the suit of clubs. So the probability then of choosing a club would be 13 out of 52. Okay. Again, how many ways can we choose a card from the suit of clubs? 13. How many cards are there altogether? 52. So there's 13 out of 52. That's the probability. All right.